Okay, now that you've learned how to solve systems of equations in 2 variables, we're going to look at systems of equations in 3 variables. Okay, so now we're going to have x, y, and z. And we're going to solve it by hand. We're going to use elimination. And what we're actually going to do is use these first 2 equations to eliminate a variable. Then we're going to look at the second 2 and eliminate a variable. And then we'll actually be in the case of having a system of equations with 2 unknowns. We'll solve that. And then we'll substitute everything back into one of the equations to get our last variable. Okay, so the fancy word for this, and you could actually do this if you had 4 variables or 5 variables or however many variables. You won't see any higher in this class. But this is called Gaussian elimination. And that's after the mathematician Gauss. Okay, so we're going to start with what I circled blue. Okay, and I'm going to leave the first equation alone. And the second equation I'm going to multiply through by -3, so that in the first equation we have a coefficient of 3 on the x, and then the second one will have a -3. Okay, so I've multiplied through. Now I'm going to add, and you'll see that our x's are eliminated. So we get -11y plus 13z equals -5. Okay, now I want to look at what I circled in red. So I'm going to multiply through the second equation, what's the top in the red, by 2, so that we have 2x plus 6y minus 8z equals 4. And then I'll bring that third equation, 2x plus 5y plus z equals 19. And now we're going to add those, and you'll see that we've eliminated the x's. And it was very important to do this so that in both cases the same variable was eliminated. And it wouldn't have to be the x each time. Here that kind of worked out nicely. But you just want to make sure that in both cases the same variable is eliminated. So here we have 11y minus 7z equals 23. Okay, now we're actually pretty lucky here because you'll notice what we're left with is a system of equations, and the coefficient on y is opposite of each other. So we'll actually now be able to do elimination on those 2 very easily. Okay, so I'm going to bring down the -11y plus 13z equals -5. And I'm going to bring down what I had in red here, 11y minus 7z equals 23, and we're going to add those. And so here, if a variable didn't, eliminate right away, you would do elimination just like we learned about with 2 variables. But here we got lucky. These cancel out, and we have 6z equals 18. So we can divide both sides by 6, and we get that z equals 3. Now, to find our other 2 variables, we're just going to kind of work our way up, okay? So we have our z equals 3. We're going to plug that into our 2 variable equation to get what y is equal to. So we can do -11y plus 13 times 3 is equal to -5. So we'd have -11y plus 39 equals -5. So we'll subtract 39 from both sides. So we get -11y equals -44. Divide both sides by -11, and we get y equals 4. So we now have y and z. We're going to go all the way back up to the top and get one of our original equations. It doesn't matter which one. Let's just take the top. So 3x minus 2y plus z equals 1. 3x, oops, minus 2y plus z equals 1. So we're looking for x, so 3x minus 2, the y was 4, plus the z was 3 equals 1. And now we're just solving for x. So we'd have 3x minus 8 plus 3, so it'll be minus 5 equals 1. Add 5 to both sides. 3x equals 6. Divide both sides by 3, and we get x equals 2. So here we can see that our x equals 2, our y is 4, and our z was 3. So our solution, we can write it instead of, we can write it x, y, z. So 2, 4, 3 would be our solution.